Hey everyone, this is Miss Morales here. We have a new lesson, 7.7, solving a quadratic function using the quadratic formula. Alright, so in this lesson, I will be showing you guys a formula that we can use to solve for our x values in a quadratic function. So when we have our quadratic function, it looks like this. We have an a b, and a c value. And if we want to solve for x, we can use the quadratic formula to do so. So here's the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So what you're going to do is find your a, your b, and your c values and just plug it into the formula, simplify it, and you should get 2 values for your x. Okay, so make sure that you write this formula down because we will be using it in today's lesson. Okay, so let's move on to our first example. So what I want you guys to do is to solve using the quadratic formula from above. Our quadratic equation is 5x squared minus 10x minus 120, and it's equal to 0. We want to solve for x. So very first step is to make sure that our quadratic is set equal to 0, and it is. So we're good to start moving on to our next step, which is to identify our a, our b, and our c value. So a is 5, b is negative 10, and c is negative 120. Okay, so now we're just going to write out our formula, and we're going to replace our a, b, and our c values into the formula. So the first part is our negative b, so we write down negative 10 plus or minus the square root, and then we put b in again, squared minus 4 times our a value is 5, and our c value is negative 120, and the whole thing is over 2 times our a value is 5. Then you can just plug that all into a calculator and you'll get your values. You can also just kind of simplify as you go. So on the top we have 2 negatives, making it a positive 10, plus or minus the square root. Negative 10 squared is a positive 100, minus, and then 4 times 5 times negative 120 gives us positive 2400, all over 2 times 5 is 10. Then we have the inside of the radical giving us 2500. And then the square root of 2500 is going to be 50. And that will give us either x is equal to 10 plus 50 over 10, or x is equal to 10 minus 50 over 10. So that's what that plus or minus part here means, is that we'll split it into our 2 answers that we have. So here we get 60 over 10, which is 6, or here we get negative 40 over 10, and we get negative 4. So there are 2 answers, and we can write it together in our curly braces as so. Okay, let's move on to our second example. And same thing, we're going to solve our quadratic is going to be 10m squared is equal to 8. So this one's a little bit different. We need to set it equal to 0 first. So we're going to subtract 8 to both sides, giving us 10m squared minus 8 is equal to 0. Just like in our last problem, we're going to write down our a value, which is 10. Our b value is 0 because there is no m term, and then our c value is negative 8. Okay, and then if you recall the quadratic formula, negative b plus or minus the square root, b squared minus 4ac all over 2a. We're just going to take our a, our b, our c values and plug it into the formula. So we get negative 0 plus or minus the square root of 0 squared minus 4 times 10 times negative 8 all over 2 times 10. So this is nice that our b value is 0 because that is just 0 and that's 0. So really we're just getting plus or minus the square root of negative 4 times 10 times negative 8. And that gives us positive 320 all over 2 times 10 is 20. Now when we separate this, we'll get two answers. The first one's either x is equal to positive square root of 320 over 20, and the other one will be negative square root of 320 over 20. But we can actually simplify this because we know that the square root of 320, we can do the factor tree on that. So let's do that on the side over here. 32 and 10, 2 and 5, 16 and 2, 4 and 4, and then 2 and 2 for each of those. So we see that we have 1, 2, 3 pairs of 2's, and if we multiply them all together, 2 times 2 times 2, that gives us 8. So each of these square root of 320's are going to simplify to 8 square root of 5, and it's still over 20. But then we can also see that the 8 and 20 both have a 4 in common. So we can actually divide that fraction and simplify it, giving us 2 square root of 5 over 5. And then this one is going to be x is equal to negative 2 square root of 5 over 5. So that would be our final answer. And you can also write it as x is equal to plus or minus 2 root 5 over 5. Okay, so the next part I'm going to show you is going to be the discriminant. So I'm going to have an image here for you guys to look at. All right, so the next part of our lesson is going to be about the discriminant. The discriminant is going to be b squared minus 4ac. That's what's underneath the square root in the quadratic formula, b squared minus 4ac. Now, when we plug in our values, a, b, and c, into that formula, we're going to get three different outcomes. Either the discriminant is positive, 0, or it's negative. So if it's a positive number, that means that we have two real roots. Visual looks like this. If our discriminant comes out and it's 0, that means it's one real root, and that's called a double root. And a visual looks like this. And then if it's a negative number, that means we have two imaginary roots. So there's no real roots, and our graph looks like this, and it's not touching the x-axis. Okay, so let's use this to do our next example. So in this example, I want you guys to find the discriminant, use the discriminant to determine how many solutions your quadratic has. So find the discriminant and determine the number and nature of solutions. So 3x squared minus 2x plus 5 is equal to negative 12. Just like when we're solving, we need to make sure that our quadratic is set equal to 0. So we're going to add 12 to both sides, giving us 17. And then also we're going to start off writing out our a value, 3, our b value is negative 2, and our c value is 17. Now, this one, we only need to use the discriminant formula from above, b squared minus 4ac, not the whole entire formula. So we're just looking at the discriminant in this example. So we plug everything in, negative 2 squared minus 4 times 3 times 17. And then when we plug that all into the calculator, we end up getting 4 minus 204, and then we get negative 200 is our discriminant value. So looking back up at that chart above, when we have a negative number, that means we have 2 imaginary roots, and that also means there's no real roots. So we can write out 2 imaginary roots. So that just means that we have a negative number in the square root, and we can't take the square root of a negative number. So that's why we say they're imaginary. Okay, so let's do another example, and we will use the same directions as above, but let's look at a different quadratic. Okay, so example 3x squared plus 17x minus 2 is equal to 3. Okay, our first step is we're going to set our quadratic equal to 0, so let's move that 3 over, giving us 3x squared plus 17x minus 5, and now it's equal to 0. We can state our a value is 3, b is 17, and our c is negative 5. Above, we had our discriminant formula written. It was b squared minus 4ac. And then we're going to just take all of our values and plug it in, giving us 17 squared minus 4 times 3 times negative 5. Okay, 17 squared is 289, and negative 4 times 3 times negative 5 is positive 60, and when we add that, we get 349. All right, this number is positive. So if we look back at our chart up here, when we have a positive number, that means we have 2 real roots. So we can go back down to our answer, and we can write 2 real roots. So that means that if we were to do the whole quadratic formula on this quadratic, that means we will get 2 real roots as our answer. Okay, so that's it for today's lesson, and I hope you guys all have a great day and stay safe.